Good morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and today we are into our question number 10 of interview preparation series. See, we all have reached till question number 10. And today's question is really, really interesting. Why DNS is so important for internet? Believe me, if there is no DNS, there is no internet. If you don't believe, I have a story around it. So in 2016, people were trying to access Netflix. They wanted to watch movie, but they couldn't. Then they tried to listen the song on Spotify. They couldn't. They tried to do something on Amazon, maybe some shopping, and they couldn't. They wanted to see CNN for the news, but they couldn't. And the reason was they were not able to access the internet. So was all these servers down at a single point in time? No, it was not the case. Actually, there was an attack on DNS, right? And because of that, it seems at that point of time that basically internet is not working. If you want to understand it, you need to understand few things, and that is the agenda of today's session. First thing first, our trademark, we would like to understand why behind DNS. Then we will be talking about what exactly DNS does, right? Point number three, if you really want to go into deeper to understand DNS, we need to understand two concepts. One is hierarchy, right? And I think you all know about it, but I will be explaining it. And then a protocol which is known as UDP, right? I think we have discussed about TCP, but in today's although the session is based on DNS, but we will be touching a bit about UDP because if we don't explain it, believe me, DNS works on top of it. At last, we will be seeing the packet flow and actual packets on Wireshark. So if you are with me, let's start our journey that why DNS is so important for internet. And it is one of the most frequently asked questions also in interviews, right? So here is our first board where we have this simple pictures, right? We have a picture of a family where we have father and mother with two kids. And we all know our parents like to call us with name, right? For them, name is important. In fact, for humans, name is so important. And then you must be thinking, Mr. Vishnu, we all know about it. What's new in this, right? But when these kids go to their college, right? The college has different department. By the way, I will be talking about these departments like computer science, math, when I discuss about hierarchy. But when these kids go to college, right? College maintain a register. And what exactly in that register is every student in this college will be assigned a number. And by the way, we call it a roll number, right? So we have this roll number and then we have the name. For example, if you consider this guy here, whose roll number is 312, right? And if anybody is interested in knowing the name, then basically we can go into this register and check the name. Because for college, it is very easy to handle all the things with the number instead of name, right? Similarly, I think you all have your roll numbers in your school days, in your college days. But now you must be thinking, Mr. Vishnu, what are you trying to say, right? Here, if you see college, right, the college system, it is it is dependent on the numbers, right? But to humans like us, we all are dependent on name because it's more human, right? And exactly this was the problem which was happening around 1980s, right? Computers, we all know, work on TCP/IP, and they have network layer, and network layer we have IP addressing. So every computer is going to have IP address, right? But humans can't remember IP address; they remember name, right? And if that is the case, that was a problem. So let's start our journey with that era only when we have a network like this. right? And this network has few PC, right? So I'm talking about something where we are in around 1980s era. Suppose, right? We all know that around 1975, we had TCP and IP. It was working fully, 1975, 1978, and two computers were started talking at that moment. And then we started making small networks. Suppose we have network number one, where we have few personal computers and we have few servers. And this network is growing, by the way. Every computing system, every host or a computer will be having an IP address. Suppose this guy's IP address is 192.168, say 3.2. This guy's IP address is 192.168, say 3.5. If they want to communicate with each other, suppose if this human wants to communicate with the human or the machine that belongs to this human, first thing first they need to ask what is your IP address. Otherwise, if I don't know the IP address, I cannot communicate. This is the first rule in computer networking. I should know your IP address to make a communication between us. As simple as that. But try to understand now, in this network, there are more than, say, 70 or 80 hosts. As simple as that. And how you are going to memorize which IP address belong to which PC, right? It is difficult. It's 100% difficult for a human being, right? And that is where somebody suggested a solution. And he said, why don't we give names to these machines? And then we are going to maintain the register just like the college did, right? And this guy did exactly the same, right? For this small network, he made this file and he's saying that this is the records of computers' names and their IP address. So what this file does, this file actually stores the names. Let me change the pen. Let me change the pen and the names and corresponding IP addresses. That is it, right? And suppose now we have 70 or 80 computers, we have 70 or 80 lines in this file, which I will be downloading on my PC. And now my PC understand what is the IP address corresponding to a particular name, right? For example, suppose I want to talk to this computer and I know this computer belong to a person whose name is Rahul. I will be saying here in my browser, I want to talk to Rahul. And now the system is intelligent enough to check what is the corresponding IP address of a machine whose name is Rahul. And then we are going to get the IP address, say 192.168, whatever, 3.7, 3.8, or whatever, right? It's very, very simple idea. And why did we have this idea at that moment? The reason is because humans understand name. Humans like names instead of numbers. You all know about it because memorizing numbers is difficult. But one thing which you need to concentrate here is the entire internet was working on IP addresses. So I can assign the name to all these machines, right? But everything is working on IP address. So there is there, there is there has to be somebody who has to convert these names to IP addresses. And here in this case, in the case of this small network, that something, that system is actually this file, right? But you all know what is going to happen around 1980s, 88, 1990. This number of computers are going to explode, right? Internet was growing like anything at that moment, right? At that point of time. But this guy didn't lose hope, right? And he was still maintaining this host file. Now, let's take an example of four networks right now, right? And suppose every network has 500 hosts or computers. So we can say that we have 2000 hosts now. And this guy's life was miserable. Why? Because he had to maintain all these records. If a computer adds, he has to add all these information. And what was the information here? Simple. The information was IP and name, and everybody has to download this file on their computers so that they can communicate with the names. As simple as that, right? But try to understand maintaining all this information in a single file. It's a painful job, right? And now in today's world, we are talking about millions of computers which are on internet. We can't put all this information on this single file, and we can't be dependent on somebody to just update this file and I will be downloading it again and again whenever there is change in it, right? It's a problematic. But try to understand, when we start doing something, we start with a simple solution, right? I'm not saying that further it is going to be complex. DNS is still very simple, but yes, we just want to make sure the system work with names, and that is why we have created this file. But when the internet grew, right, this file was not enough. It was very difficult to maintain and manage it, right? So we need somebody, a system, right, which can give us the IP address corresponding to a name. And now these names are huge, millions and millions of the names are there on internet. We want now, we do not want this file, we want a complete system solution, right? And that is that solution which gives us the IP address corresponding to a name, and we call that solution DNS. We do not know how exactly it works. But till now, we just know that there is a file where we were managing all the records. But now the solution was not enough. Why? Because huge number of devices are available on internet, and that is why we have to move from this file to somebody else, and that somebody else is DNS. So I think you all understand till now, why do we need something, right, which is DNS. So I am saying the replacement of this host file is the DNS, by the way, right? And you need to understand that why do we need that, right? Because it was very difficult to manage and maintain the complete network through host file only, right? If you are from Linux background, I think you have heard about host file also, right? By the way, I think on Windows host file is there. But now let's talk about what exactly this solution does. It's very simple, right? We have a machine, we have a client machine right here, or any host, and this host wants to reach to Miro.com. And here you go. You must be thinking, Mr. Vishnu, why Miro.com? Everybody explains with www.google.com, right? Why Miro.com? The reason is simple. As I mentioned, as I promised in the beginning of this session, right, that I will be showcasing all the DNS packets on Wireshark. And the packet which I got is from Miro.com. That is why I have put Miro.com right here. So everybody is connected to internet. Miro.com is also connected to internet, and this guy is connected to internet. This guy opens the browser, right? And he's fond of names, not numbers. So he just write Miro.com here, right? Interesting. But now the problem is, on the internet, there are many routers connected, and these routers actually understand IP address. So if you send a packet where the source is something, maybe this guy name, maybe Rahul, and the destination is Miro.com, and when this guy reaches to this router will say, no, I do not understand where is Miro.com. I only understand IP address. So we need to replace these two things with the IP address, right? Otherwise, system won't work. And that is the whole sole duty of DNS. Maybe suppose right now we have a cloud. I do not know about that, but this is my DNS. What exactly the duty of this DNS is, that this client machine or this host is going to ask this DNS that, tell me the IP address of Miro.com, please. Why? The reason is that internet work on IP addresses. I I know that I want to communicate with Miro.com, but I do not know the IP address. Mr. DNS solution or system, can you give me the IP address? And believe me, this DNS system will give you the IP address. It means that this is still the same register or same file, or it's a complete system, how exactly it works. And this is the whole sole point. So basically, when the system or the client asks what is the IP address of Miro.com, this DNS is going to say the IP address of Miro.com is 200.10.10.10. As simple as that. This is the whole sole purpose of DNS. This is what exactly DNS does. Now we need to understand this cloud, how exactly this works. Why? Because we have so many computers on the internet. How come this system stores information about it? How come this system, right? It's very interesting to know which approach it is going to follow to save all the information about the names of the server on internet. And then whenever we ask, it is going to give us the result. Because if the DNS system is not there, then we will not be having the IP address. And if we if we don't have IP address, believe me, we cannot connect to Miro.com on any server. Right. Now, to understand this, how DNS work, we need to understand two concepts. We need to understand hierarchy and we need to understand UDP. Hierarchy is simple, right? Maybe for some people, hierarchy name is a bit confusing one, but hierarchy means organizing large information into layers, right? And then you must be thinking, Mr. Vishnu, what is the meaning of large information? Try to understand. We have huge information and we are making a system, right? The cloud, which I make the green color cloud, I am just asking the cloud, tell me the IP address of Miro.com, Google.com, Amazon.com, anything, and it is going to reply with the correct IP address. It means that in that system, we have huge information. If we want to organize that huge information, right, we need some technique so that we can get the information, whatever we want, right? And to organize that information into multiple layer is known as hierarchy. It is not a new concept, guys. Believe me, as I mentioned that in these universities where many students are there, this university is actually, right, using this approach. And you are also using this approach when you define your address. For example, suppose we have Mr. Rahul, right, who is part of computer science and engineering department in college one, and this college one is part of this university, right? I can reach to Mr. Rahul with all this information. I just need to write Rahul, right? Dot maybe CSC, maybe college one, and then university. It means that Rahul is part of computer science engineering department inside college one, inside this university. As simple as that. All this information is arranged in hierarchical manner. And try to understand there are many students in different colleges of this university, but university has done one thing. It has organized this information into multiple layers so that whatever the information you want, you can get it easily. Similarly, if you consider your address, guys, means on this earth we have multiple countries, right? In multiple countries many people live. For example, in India there are more than 1.5 billion people, right? But how you are going to arrange this information, how you are going to arrange this huge information. Suppose if I want to if I want to reach to some guy whose name is Rahul who lives in India, right? How I'm going to reach? I can reach to that guy address if I know this complete structure, right? And all, by the way, knowingly unknowingly we have been using it. This is our address. So I am again repeating the same example, but with a different analogy this time. Right now, suppose Rahul lives in Bangalore. Bangalore is part of Karnataka, which is the state in India. And eventually, India is a country, right? So there are country. So basically, we call it a route. To find the information, we have to start from somewhere, right? And that is my route. Inside this route, we have multiple countries, maybe more than 200 countries we have, and that inside that we have different states, right? then cities, maybe then the local area here, right? So overall, the meaning of hierarchy is arranging huge information into multiple layers so that whenever you need that information, you can get it easily. And that exactly we are doing in case of DNS also, because the problem is same. Why the problem is same? The problem is same because we have huge number of servers who have name, and we need to find the IP address. Means we have to store this information, name and IP address of which is really huge, and that is where we have done some great job here. So we have defined, or we have arranged this information also in the form of hierarchy. Very simple, right? So as I mentioned that we need to start from the root, and by the way here we have, because we are talking about computing system, we are talking about internet. On internet, when we want to store information, the huge information, we have servers there, right? So when I say root, the meaning of root is a server which stores some information, right? So I am 100% sure that you have heard about various types of name. For example, google.com, something.org, something.edu. So we have organized these names into multiple groups, right? We start with the root. And by the way, there are seven. I'm not sure how many multiple groups like .com, .edu, .org, and there are multiple others also, right? So we have arranged this information just like country. Inside the country, we have different states, right? Similarly, inside this root, we have com, edu, or so. For example, if I want to search information regarding .com, I am going to this server and asking them, right? This server knows all the names which end with this .com, right? And then suppose I want to ask Miro.com, then I will be asking, do you know about Miro, Mr. .com? And he'll be saying, yes, I know a server who can give you the IP address of Miro.com, and this server is this one. And this is the way we have arranged all the names and IP address information inside these servers. Some top level server, these servers doesn't store the IP address, but they store the information of the servers, which can tell you the exact IP address. And this is how the entire hierarchy is managed and maintained. Who maintains them? Different companies. For example, these .com, edu, org is maintained by VeriSign, right? I think root is also maintained by them. I think there are 13 root servers also, but if that is fine, means the whole sole purpose is to explain you the meaning of hierarchy. Means if you want to arrange huge information, arrange them in layers so that you can get the information very easily whenever you want. Now, hierarchy is done. I have taken almost 7 to 8 minutes because this is the place where many students, many people get confused. Now, let's talk about UDP. What is the meaning of UDP? We all know that the TCP/IP has 5 layer structure, and it has transport layer. Transport layer has two protocol, TCP, and by the way, we had a very good discussion about TCP/IP, right? Specifically TCP, the three-way handshake, everything, right? There is one another protocol. The protocol name is UDP, and it is totally different than TCP. First thing first, if I talk about TCP, the main motive here is first to maintain the connection, first to check whether whoever I am talking to, maybe Miro.com, whether that server is there or not, available or not. If it is not, then there is no point, right? And then this guy also check whether you are here or not. And we all do using these three messages, SYN, SYN-ACK, and ACK. We all know about, we have discussed in this series only. By the way, it would be better if you watch all the questions in sequence. It is going to be very good learning for you, right? So maintaining first this connection and then send a message. And if any message is lost, it's the responsibility of TCP, right? to ask that message again. But there are some applications which do not need this. And you must be thinking, Mr. Vishnu, what application? No, it means if packet is lost, we have to resend it. No, there are some applications which do not need this. Suppose, I'll give you an example. Suppose here is Mr. Rahul, and Mr. Rahul is talking to Anjali, right? And Rahul is saying, hi, Anjali, hi, how are you? As simple as that, right? And then it sends this information over the wire. And interestingly, because this is going over IP, this R missed, right? We are talking over a phone, right? And the information which received by Anjali is, hi, how you? R is missed. But try to understand, this is a real-time communication, guys. If you're communicating, hi, how are you? And if R is missing, it is not the case that you will be sending that R after some time. No, right? There is no point, right? So in real-time communication, you do not need somebody who is always maintaining that which packet is missing. And that is the whole sole duty of TCP, by the way. If something is missing, then it can ask again, right? It gives you the reliable delivery, the TCP, which works on top of IP. So there is a protocol which do not need this initial communication. It just depends on IP that it consider that, yeah, it is going to deliver my packet, right? And if it doesn't deliver, then I will send it again, right? Interestingly, and that protocol is UDP, which doesn't make any connection. Instead, the packets is very packets are the packet of UDP is very small because it has only source port, destination port, checksum, and I think the length. Only 4 fields. If you consider TCP message, it's a huge, right? I can spend around an hour in UDP, but the whole sole purpose here is that you should understand when I showcase you the Wireshark packet of the DNS, sorry, DNS packet on Wireshark, you should understand that why UDP is coming into picture. One more thing, when we were developing this DNS system, try to understand at that moment speed matters. And when the packet is small, it can go on a small bandwidth link also, right? And that might be the case that these people decided that my DNS packet will go on top of UDP. What is the meaning? I will be explaining you. Do not worry about it. So two concepts which we have understood here is hierarchy as well as UDP. And now, believe me, we are in very good condition to understand the packet flow of DNS. And here you go. What is happening here is how DNS works and packet flow. Again, I think we all understand till now that all the information, IPs and name was arranged in this hierarchical manner in different servers, right? We all know it. And now we know that we can get this information very easily. So the problem is simple. This guy is still here, right? And this guy wants to communicate to Miro.com. And he has opened his browser, right? Just written Miro here or Miro.com here. Now what is going to happen? He need IP address correspond, and this is the whole sole purpose of the DNS system. Whatever we are arranging the huge amount of information into this manner, hierarchical manner, the aim is to get the IP address of a name, right? Wherever I want to be, maybe google.com, amazon.com, miro.com. I just want this IP address because to begin with, I just know the name of the website or the server. I really do not know the IP address. So if I give you this problem, you would be saying, Mr. Vishnu, it is easy, right? You can ask this guy, communicate to the root and ask where is .com, and root is going to say that .com server is this one, right? And root is going to reply that maybe suppose this server name is 5.5.5.5. So first, if I want to ask Miro.com, I know that the information is available. I am checking, I'm just going to the root and root has just replied 5.5.5.5. right? And now this guy say, okay, because root is just saying that I do not know about Miro.com, but I know a server who might know about Miro.com. And that server is .com server, which is 5.5.5. Go and ask it. And Miro.com, sorry. And this guy now is again going to ask.com. Do you know, because you are a .com server, do you know where is Miro.com? And this guy is saying, no, I do not know, but I know a server who know where is Miro.com. And the IP address of that server is maybe say 3.3. I am taking any arbitrary IP address, but try to understand. भावनाओं को समझो दोस्तों, right? 3.3.3.3. And this guy .com is going to reply ask 3.3.3.3, and then this client is going to ask 3.3.3.3 what is the IP address of Miro.com, and this guy is going to reply the IP address of this is 200.10.10.10. Interesting, but don't you think it's a whatever the solution suggested by you, right? It's a little bit asking a too much thing from the client. First client has to go to root, then .com, then Miro, and this guy is again and again asking, right? Can we make it better? Believe me, we have made it better, right? So instead of you asking everywhere root.com, then the Miro server, what exactly happens? You just ask with only one guy, right? Tell me what is the IP address of Miro.com. You just ask this over this UDP protocol. What is the meaning? I'll tell you. You are just saying, give me the IP address of Miro.com. And this guy is going to reply. And whatever you were doing previously, going to root, going to com, going to Miro, this is the responsibility of this guy, and we call this as a DNS server. And if you have heard about 8.8.8.8, this is the Google DNS server, which does exactly this thing. Now we are in 100% position to understand the complete flow of DNS, how exactly it works. So basically, what exactly happens, this guy writes on its browser, give me the IP address of Miro, or we just write Miro.com, and the system doesn't work until and unless it gets the IP address of this Miro.com, right? So browser will ask that whether do you know, browser will ask itself, by the way, do you know about Miro.com? And it will say, I am considering that everything is new, 8.8.8. It just booted up. No information is there at all, right? Because sometimes browser, most of the time browser also cache the information. So this browser is asking himself, do you know about Miro.com? And it says, no, I do not know. And then the browser asks the operating system, do you know about, because operating system also does caching. The meaning of caching is store information. Do you know Miro.com? And operating system say, no, because I'm saying everything is new, right? Then what exactly happens? You configure one special setting here in TCP/IP that to know the IP address of any name, just go to 8.8.8.8. I think you must have seen in your network properties that this is your DNS server. By the way, 8.8.8.8 is the DNS server name of Google, right? Similarly, we have, I think, 1.1.1, which is a Cloudflare DNS, very, very interesting IP address, right? Now, operating system doesn't know about Miro.com. So OS will say that the communication will never work until and unless I have the IP address of Miro.com. And that is why I am going to ask 8.8.8.8 because somebody has configured this thing for me, right? And by the way, this guy will be creating a packet. And now 8.8.8 is an IP address and which is connected to internet. So definitely we can reach out to it. So this guy is going to say my source is whatever, right? The source address of this Rahul machine, whatever, right? IP address. The destination is going to be 8.8.8.8. And inside this, the packet will be going. And in this packet, we call it the DNS packet. It will be asking what is the IP address corresponding to Miro.com. Tell me, Mr. 8.8.8. I am making it very simple. By the way, between them, there is a UDP packet also, UDP header also, by the way. Right? Why? I'll be telling you. I'll be showcasing you in the Wireshark. Don't worry about it. So this guy is asking, what is 8.8.8.8? Sorry, what is the IP address of Miro.com? And now this guy get this information. By the way, this is a very powerful server. Why this server has to be powerful? I'll tell you, right? This guy stores the information inside it, right? It will check it in in its cache that whether it knows about Miro.com. By the way, I'm saying that every system is new, so 8.8.8 also doesn't know what is Miro.com, where is or what is the IP address of Miro.com, right? And now the interesting thing happens. Instead of you going to root, this guy 8.8.8.8 will be going to root. And by the way, this guy knows the IP address of all the roots. By the way, there are 13 root servers available all over the world and all the information, and it will be going, I think, the nearest one. How? We can talk about it later in some routing class, by the way. Here, it will go to this root and it will be asked, tell me where is what is the IP address of .com server which will give me this Miro.com, or you just give me the .com server address. And root knows it, right? Root has the information about .com, .edu, .org, and it is going to say that, see, here is the IP address. Suppose 5.5.5.5 is the IP address of .com server. So it will be replying that ask 5.5.5.5 because this is the .com server, right? And then 8.8.8 will be going to 5.5.5. Can you tell me the IP address of Miro.com? Interesting, right? And then this .com server will say, no, I do not know, but I know a server who might have or who will have, right? Who will have the IP address of Miro.com, and that server IP address is maybe say 3.3.3.3. Go and ask it. So it will be replying with this. Then go and ask 3.3.3.3. And then this guy will be asking to 3.3.3, do you know the IP address of Miro.com? And this guy will check here and it will reply that yes, I know. And the IP address is maybe say 200.10.10.10, and it is going to reply with this address. Wow, right? Previously, whatever the solution we were thinking, everything was done by this client, but now all the problem is solved. You are just asking only one guy, 8.8.8.8, and this guy, this server is doing all the work on your behalf. Isn't it beautiful, guys? Right? And eventually, when it gets that the IP address of Miro.com is 200.10.10, after looking up all these things, this server will be replying the client that the IP address of Miro.com is 200.10.10.10. As simple as that. Guys, try to understand. It is not the only case that you just need to organize the information. You have to make this complete system very easy for the end host. And it's very easy, right? On the end host, whoever wants to know the IP address corresponding to a name, we just give the IP address of a guy who can do all these activities. By the way, this activity, which this 8.8.8.8 is doing or on our behalf, we call it as recursive activity. Why? Because you are asking this guy only once, and whatever is needed to get this information, the lookups in .com It is going to ask the .com, sorry, the root, where is the .com? Then .com, where is the Miro server, right? Right? It is the recursive lookup. This is the meaning of recursive lookup. You do not need to do that. And host doesn't need to do that. 8.8.8. Now, you must be thinking, Mr. Vishan, that is fine. Can you now give us some terminology also? We get that, we get the basics, right? So by the way, this 8.8.8.8 is known as resolver. Why resolver? Because it resolves. So 8.8.8.8 is the Google resolver, right? Very, very important. And to begin with, I mentioned that this guy needs to be very strong, right? Very powerful. Why? Because, see, you are asking where Miro.com is. There are many thousands, billions of people asking, maybe where is Google.com, Amazon.com to the same guy, right? He need to process all this information, by the way, right? That's why it needs to be strong. And the second thing is, once it get the, see, now it got the IP address of Miro.com, so it will be storing this information in its cache, so that if any other guy comes and asks for Miro.com, it doesn't need to do again and again that recursive lookup, and it will reply from its cache. As simple as that, right? Interesting. So overall, this is the total flow of the DNS package. By the way, this is known as resolver. Now let's talk about what are these server known as .com, edu, and org. These are known as TLD. The meaning of TLD is top level domain, right? .com, .edu, .org, and there are multiple such servers, right? Just like the countries we have, India, Bangladesh, maybe Australia, US, just like this. Hierarchical information, right? Very simple. And then the guy who is eventually replying, right? This is known as name server. What is the meaning of name server? The meaning is this guy is actually having that entry. By the way, root doesn't contain the entry name to IP address mapping. No, they just know where the top level domains are. That is it. .com knows, right, where you are going to find this entry Miro.com, and which is going to be inside the server, and this is known as, this server is known as the name server, which actually replied to resolver that the IP address of Miro.com is 200.10.10.10. This is known as name server, and by the way, this has the authority to reply. We also call it authoritative name server. As simple as that, right? Now we would like to see all these things, whatever I mentioned, into Wireshark also. So we have a packet which I have captured, right? What is happening here is, see, the important thing. So as I mentioned in my previous sessions also, that now you have understand the encapsulation process. So first thing first, we call this as a DNS letter, right? From here to here. This is my DNS letter. What exactly inside is, just try to understand. It is saying that I would like to have Miro.com IP address, and it's a standard query, right? It's a standard query. I would like to know the Miro, and this is a type A. By the way, type A means IPv4 address I am interested in. If it is A means 4 times A, and by the way, IPv6 address is 4 times of IP address. That's why maybe they have written for IPv6. So it's a standard query for IPv4 address. I would like to know IPv4 address of Miro.com, right? This is the DNS packet. But if it wants to go, right, we need to encapsulate it, and it will be encapsulated in another packet, which is my UDP packet, which you can see from here to here. The source port is going to be any arbitrary port, that is, and the destination port is going to be 53, which you all know that the destination port for DNS is 53, by the way, right? And then if it needs to go over the IP network, we need to again encapsulate it where in IP packet, and the source IP address is this. But although we have IPv6 addresses here, guys, by the way, guys, right? But we can have, we definitely see IPv4 addresses also here. So this was my standard query message. And see what the server is replying back now. It's again very, very interesting. See here. So the server is replying again with a DNS message, right? We have this DNS letter, and this is saying these are the addresses of Miro.com. We received 4 different IP address. Why 4? Because this Miro.com, very popular website, right? They have huge number of servers, and they are saying that basically we have these IP address. Which IP address will be chosen by the end host or the host which is asking for this address? The first IP address. If it is not reachable, then the second, and maybe all right. This is for redundancy sake. We got the IP address, right? It got encapsulated in UDP message, and the source port is going to be 53 because it is now coming from the server. Which server? The resolver itself, by the way, because the end client will be asking from the resolver, right? And my pen is very in bad situation. So sorry for this. Let me. So I think you got the idea now, right? And of course, source port is this, destination port is this, and again the source IP and destination IP. I think you understand the encapsulation because we have been doing this from last 9. And if you go in particular order from question number 1 to question number 10, you will be having a very, very deep dive into the networking, because 10 questions means almost 10 hours of networking, right? Now, I would like to talk again with that attack which happened in 2016, right? How people have done that attack, right? So we have discussed the concept of name server, right? Authoritative name server. For example, we have a server, and in this server, we will be having a name to IP record of many other servers like google.com, amazon.com, and so on, right? So there was a company, the company name was Dyn, right? In 2016, this company was responsible for managing and maintaining the record of Amazon, Twitter, Spotify, CNN, and Netflix also, right? So what the attacker did, they send lots and lots of malicious or the traffic, normal traffic to this guy. Then, and this Dyn server was processing, right? Whatever the traffic is coming. And the main job of this server was to reply, where is Netflix? Where is Twitter? Because this server was so overwhelmed with so many packets, it was not able to do its proper job. And by the way, we call such attacks as denial of service attack. And people were not getting the IP address of Twitter, people were not getting the IP address of Netflix, and so on. And that is why everybody thought that internet is down, but that was the attack on Dyn server. Just have a look at it, the Dyn attack. You will be amazed to see that how simple this attack was, but it resulted into massive outage of these websites. Hope you have enjoyed this session. I will see you in the next session where we will talk about one of the most interesting, not one of the most interesting, but one of the most asked question, which is if we write google.com on our browser, what is going to happen? So see you in that class or session. Bye for now. Thank you so much for being patient. Thank you so much for being with me from last 50 minutes. Bye for now.